Okay, so now let's do the simulation, and we will do it using in ANSYS-Fluent. So these are the steps that we will follow. Step number 1, we will create the computational domain in Ansys Workbench space claim. And step number 2, create the computational grid in Ansys Workbench Mesh Lab. And then number 3, we will do the simulation. We will configure ANSYS-Fluent to perform the simulation in Ansys Workbench Fluent. So now let's go and focus on step number 1. Create a computational domain in Ansys Workbench space claim. Okay, so prior to opening Ansys Workbench, create a folder called 2DSSHD in a convenient location. So let me just do this with you. So I will create a folder called 2DSSHD, and it's here. I will open it. Now, the next thing that we will do is start Ansys Workbench. So go to start and type Ansys Workbench. Okay, it's not there. Okay, so what we will do then is start, go to Ansys and look for Workbench at the end. Workbench 2024 R1. So click on that one. Okay, so now our project or Ansys Workbench is here. Everything is good. No, we have different panels. We have the Toolbox panel, the project schematic panel. So in the Toolbox panel, you will see a toolbox of various analysis systems. On the right, you will see your space, right? Your workspace. This is the place where you will organize your project. And then there is this project of properties of project, right? Okay. Now, we want to use ANSYS-Fluent, and in particular, we want to model heat transfer. So to do that, click on Fluid Flow, Fluent, drag. So click and drag, and now name this as 2D heat transfer of a solid. Okay. And now we will conduct the analysis. Before that, just let's save this project. File, save as, and then select your folder. We will name this as project 1. Okay, so now this is the project schematic. And to be able to visualize the results, we need to do these steps. First, we need to create a geometry. Then we need to do an image. Then we need to set up our simulation. Then we need to conduct the simulation or the solution. And then we will be able to visualize the results. Let's start with the geometry. So click on geometry. And then go to this, to the right side, and you will see all these commands. The one that is important for us is the number 17, and this is analysis type. Change that to 2D. So we are done with that. Now, let's open the software where we will create the geometry. Since this is a 2D simulation, it's a very simple computational domain. So what we will do is right click on geometry, then go to and do click in new design modeler. So do click on new design modeler. Okay, so this is where we will create our geometry, our 2D plate geometry. So click on the Z-axis. So now we have a 2D view. And now what we will do is properly adjust our bar. So see, right now it is 0 and it is 30. Remember, our plate is 5 meters in length. So what we will do is click on this one, on the zoom, and then with the middle button, you can rotate it and make it 7 meters. So this way, the screen will have the dimensions that will allow us to visualize our geometry properly. Now, so yeah, just look at the scaling bar, right? And make sure it has a right length. You don't want it to be 500 meters. That will be too long. You don't want it to be 1 millimeter. That will be too small. Okay, so now click on the sketching toolbox. So here on the left, do click on sketching. And you can see all these options that we have to create our geometry. Click on rectangle. Now, put your cursor at the center and make sure that the letter P appears. That means that you are right at this point. Now do click and drag. And remove the click. Okay. So now we have our rectangle. So now what we will do is dimensionalize or put the dimensions of our rectangle. So we want to have a horizontal dimension and a vertical dimension. So click on horizontal, then click on your horizontal edge of your rectangle and click on the top. Okay, so click and drag. Okay, no, let's try again. So click on horizontal, then click and click. Okay. Okay, this one is tricky. Let's see. So you do click on the point, click on the control and click on the other point, and then you have your dimension. So let's do now the vertical. So click on the point right at the bottom. Now control, click on your other point and drag. And that will give you your vertical dimension. So you see, there are these little tricks, but once we know them, it's easy. So now let's put our dimensions. Remember, we said that B will be equal to 5 and that the vertical dimension will be equal to 1. Right? So now we have our geometry. The next thing is to create the surface body. So click on modeling. Right now, expand your XY plane and you see there is this sketch 1. Now go to concept, surface from sketches, and select, is asking you, which objects do you want to create the surface? So select sketch 1 and then apply. Now go back to the sketch and right click on surface, sketch 1, and then click on generate. See, now we have our surface. So first we have edges. Now we have a surface. That's good. Oh, that was easy. We are done with this part. So now click. Let's save this, save project, file, save. And now let's close. Close design model. Ooh, so now we have our geometry. Now, let's just save this so we won't lose our progress. Now, let's do go to the next step, which is creating the mesh. So click on mesh, do double click on mesh, and now Ansys Workbench is starting the meshing software, as you can see here at the bottom. Okay, so this is our meshing software. Okay, what's going on? It's taking some time. It's loading the geometry, and this is our heated plate, and we need to create the computational mesh. So what we will do is right click on mesh and then generate mesh. That was easy. Now, if we want to increase the number of computational cells, what we need to do is use a tool called edge sizing. So right click on mesh, insert, and then sizing. Now it's asking you for a geometry and the type, right? So for the geometry, let's select the horizontal edges. To do that, come here and do click on edge. And select the bottom edge and the top edge. Come here and do apply. So now we have two edges. So now for the type, select number of divisions and put in here, put 50. Now let's do the same for the vertical edges. So right click, insert, sizing, select one edge, then do control, select the other edge and do apply. So remember to first select one edge, doing click on it, then press the control button and then select the other edge. Then in element size, then number of divisions, and put this as 10. Okay. So now we want to generate the mesh again. So right click on mesh and then update. Select update. So now this is our mesh. It doesn't look too bad. So we are done with this. The next thing that we need to do in this mesh is assign names to our to our edges and also to the solid plate. So we will use these names once we are defining the simulation. So now, what we do to assign names is right-click on mesh, then insert. I'm sorry. So to do the names, what we need to do is, so come here, select your edge, then select the edge at the top, right? Then do click in there. You see it changes to green color. Now right click and then create name selection. And put the name of top edge. Okay, so now do click on OK. Now go to the bottom, right click, click on it, then right click, create name selection. And assign the name of bottom edge. And do OK. Now do the same for the heated plate, right? So click, then right click, create name selection, and put the name of heated plate. And do OK. So now let's do the same for the other one. So click, right click, create name selection, and assign the name of right edge. Now we also need to assign a name to the domain, to the solid domain, right? So so what we will do is do click on face and do click on your domain. Then right click and then create name selection and assign the name of solid plate. This is our solid plate. And do OK. So now if you go to the left and then do expand the name selections, you will see all the names that were created and you can verify that this was done. So this is our top edge. You see how it shows this marker, then bottom edge, then the heated edge, the heated plate, and then the right edge and the solid plate. Okay. So that's done. Now, what we will do is update our solution or our mesh. So in this way, Ansys Workbench will know that we have created them or will assign these names to the mesh. So right click and then update. Right click on mesh and then update. Okay, so now we are done with the mesh. That's awesome. File, go to file and close meshing. Okay, so we are almost there. So now let's save our progress. File, save. So now let's go to setup, where this is where we will set up our simulation. We will also launch ANSYS-Fluent in here. So double click on setup in the Workbench project page, which will bring up the Fluent launcher. So ANSYS-Fluent. When the Fluent launcher appears, change the options to double precision. So double click, then select double precision, and then click on start. So what the double precision does is each floating point number is represented using 64 bits, in contrast to the single precision solver, which uses 32 bits. So the extra bits increase not only the precision, but also the range of magnitudes that can be represented. The downside of using double precision is that it requires more memory. But then now do click on start. And let's hope that ANSYS-Fluent will properly start. Okay, it's taking some time. It's making me nervous. Oh, segmentation. Okay, let's see what's going on. There is an error going on. Oh, and this error is, I will fix it, but just see that that's the problem. Okay, so to fix this issue, do Control Alt. Okay, the Fluent application failed to start. Do click on OK. I see ANSYS Fluent here. So I want to close this window, then fix the issue, and then start ANSYS Fluent. So then do Control Alt Delete to start Task Manager. So start the Task Manager and select CX2110, and then do click in End Task. Okay, so now ANSYS Fluent is closed, and I faced this issue before, so I know how to solve it. So what we do is, this is an issue related to antivirus. I have a McAfee antivirus and doesn't like ANSYS Fluent. So what I will do is click on the McAfee antivirus and change settings, then go to firewall. And then I will turn off the firewall for the next 60 minutes. And then close. Let's hope that that solves our issue. So then start. So double precision is selected. And let's hope for the best. Okay, no errors now. This is great. The mesh is there. It was properly uploaded. Right? So now this is ANSYS Fluent. So now everything is organized very well in ANSYS Fluent. So first at the top, you have different options, but then see the important thing here is the outline view. We have the setup, we have the solution, we have the results, right? So first we need to do the setup, then we need to do the solution, then we need to do the results. It's like a very organized way, right? But before that, we go to the top and we do a check of our mesh, right? And we also want to do the info. So let's click on mesh info, then size. And it's telling us how many cells do we have. So we have about 31 computational cells, which is good because we were expecting about 500 cells, because our mesh, remember, it's 10 cells along the X along the Y direction and 50 along the X direction. So that's about 500 cells. Right? So this is good. So now what we will do is now check our mesh. So click on check, click on perform mesh check and see if there are any errors in there. I don't see any errors. Hopefully you won't see any errors too. So that means that, yeah, we are in good shape. You can also display your mesh, right? So you can see, you can do display, see there is nothing in there, but then you can visualize your top edge, your bottom edge, then select the heated plate. It is there, the interior solid plate is there, and the right edge is there, right? Okay. So now let's do the setup. So go to general. Let's start with the setup. So go to general, double click in general, and it gives us this dash page. So general is a pressure base, it's steady. We are a steady state simulation. We are not in transient. And it is a planar simulation, right? So we are fine. There is no gravity involved. Now let's click on units. This is fine. Nothing to see in here, but see the area is meters square. So just make sure that you have the correct units. So this is fine. Now, let's go to the next step. So what is the next step? After general, what comes is models. And remember that we were solving the energy equation, right? So we need to activate that model. So to do that, just double click in energy, then click on energy equation and click on OK. Okay, so that's done. So now ANSYS-Fluent knows that we are solving the energy equation. So we are done with models. We don't have any other models. Now let's go to materials. So we don't have any fluids in there. We had a solid, but remember, it was the plate is made of copper. And maybe I forgot to mention that, but the plate is made of copper. So what we will do is click on solid, double click on solid. Okay. So right click on solid. No, okay, double click in materials. Double click in materials. So go to solid, right? And do click on create edit. So now we can add the material of copper. So to do that, go to Fluent database. Then in material type, select solid. And then look for copper. It's right there. So then once you have identified it, just do copy and do close and do close. Okay, so now ANSYS-Fluent knows that we will be working with copper. Okay, so we're done. What's the next thing in the list? Cells on conditions. Okay, so the solid, right? So double click in cells on conditions, then select the solid plate and click in edit. And then it's telling you material name, aluminum. No, it is not aluminum, it is copper. So select copper and click in apply. Close. So now ANSYS-Fluent knows that our solid plate is made out of copper. Okay, so let's see what else is in here. Now we will go to the next thing in the list, which is the boundary conditions. So the bottom edge, remember what we have at the bottom edge, we have a symmetry boundary condition. So select, so double click in boundary conditions, select bottom edge, and then click on type and select symmetry. And then apply. Now, the heated plate, that's a little bit tricky. We will leave that at the end. So now let's do top edge. Top edge is also symmetry. So select top edge. Oh, by mistake, I did double click on that. So no need to do that. So click on top edge, type, and put symmetry. This is the insulated boundary condition. And then clicking apply and clicking close. See? ANSYS-Fluent gives you many possible boundary conditions that you can select. And we will explore some of these during the course. Okay, so now at the right edge, the right edge is our infinite boundary condition, right? So it doesn't matter which temperature we put in there, but do double click in there. Really doesn't matter. So hit flux 0. You can also assign temperature. Doesn't really matter which condition you put in here because this boundary is too far from here. So it won't really affect your results. So now let's deal with the heated plate because remember the heated plate has this linear variation in the temperature. At y equals 0, the temperature is 0. At y equals to 1, the temperature is 1. So now you see, this is the mesh. These are the computational cells. So each of these computational cells has an assigned coordinate. ANSYS-Fluent is doing that for you. ANSYS-Fluent knows the center of each of your computational cells, and it knows the location of these computational cells. And we will use that information to define our condition. So double click in heated plate. It is a wall temperature condition, that's fine. Because the wall will allow us to select temperature. But see, we need to tell Fluent here that the temperature is linear and that it depends on the Y location of the computational cell. So to do that, click on New Expressions. And then name that as linear variation. So see, ANSYS-Fluent likes to have units, right? But what we will do is remove this and put the condition that we want. So under variables, we have this mesh, and we have coordinate, and we have Y coordinate. So this is the Y coordinate of what? Of our mesh. And in specific, this is the Y coordinate of the computational cells. Of which cells? The cells that are in contact with the heated plate. Okay, so that's good. Select that one, position Y. But see what Fluent is telling you. Incorrect expression unit. Expression unit is meter, but the required is Kelvin. See that? So how to fix this? It's like ANSYS-Fluent is not understanding that it's a linear variation and that the temperature is 0 at 0 and the temperature is 1 at 1. So the way to fix this is by putting another expression or modifying another expression, right? This is a very smart way of doing it. We will multiply this. right? Times one what? 1 Kelvin. So now, and divide this by what? By 1 meter. You see, it's like we trick ANSYS-Fluent. So now ANSYS-Fluent is not complaining about our expression. And then now what we will do is click on OK. Okay, so now ANSYS-Fluent has the linear variation in temperature at the heated plate. Material name, select copper. And then click in apply. And then close. Hopefully that will work. Now, what's the next? So now we are done with the boundary conditions. Right? We don't have any reference frames, name expressions. We don't have any of that. So now we are done with the setup. Do file and save. Okay, so now let's check what's going on here. Okay. So now what we will do is go to the next step, which is the solution. So go click on methods, double click on methods. And these are the methods that ANSYS-Fluent will use to solve our equations. Second order of wind. All this is being, you will review it in the class of fundamentals of a CFD. So don't worry about that. Just go to controls. And the thing here is ANSYS-Fluent thinks that we will solve the governing equations of fluid flow. This is because most users usually solve fluid flow. Right? They solve the fluid flow equations. However, we are not solving fluid flow equations. We are unique. We want to solve heat transfer on a solid plate. Therefore, we need to tell ANSYS-Fluent that we are unique and that we are only interested on the heat transfer part and that we are not interested in the fluid part. So to perform this task, so what we will do is in controls, then do click in equations and see, and then unselect flow and turbulence. So unselect, click on flow, click on turbulence. So it's unselected. Energies should be selected. So select energy. So see how energy is dark. That means that energy is being selected. So then click on OK. So now ANSYS-Fluent knows that we are not interested in the flow. So we are solving a non-conventional mathematical problem where the temperature can be also 0 Kelvin, right? That's very uncommon. How the temperature can be 0 Kelvin? ANSYS-Fluent is like, oh my gosh, what's this guy doing? So we need to tell Fluent that it's possible to have a 0 Kelvin temperature because this is a mathematical problem. So go to limits, and in minimum static temperature, select or enter a value of 0. So this is the minimum static temperature allowed, right? And then click on OK. So we enter 0. So here we should all feel proud. We are playing with ANSYS-Fluent and not vice versa. What is the vice versa? ANSYS-Fluent playing with us. No, we are telling ANSYS-Fluent, this is my problem, this is what is needed, and I'm not asking you for a favor. I am telling you what to do, and this is how you should do it. We are learning the secrets of ANSYS-Fluent. At the end of the course of CFD, we hope that we will know most of the secrets of ANSYS-Fluent. We will know the way to manipulate the software to make it obey our needs. Most of your friends in other universities learn only the easy steps. They don't learn the secrets. Okay, so now we are done with the solution. We need now to define so we are now with okay, we are now done with this part. So now go to monitors and the residuals, right? So click on residuals and see residuals of energy equation. You want to monitor them? Yes. You want to check for convergency? Yes. What is your criteria? Let's put here a very low value. Okay. And then type 1 to the power minus 12 and then click on OK. So this is the minimum this is the minimum residual value, right? And then click on OK. So we are done with this. The next thing that we will do is initialize our simulation. So we don't want report files, we don't want report plots, we don't define any convergency condition. We need to initialize our simulation. Here, we will select standard initialization. And then for temperature, we will put a value of 1. So in a steady state simulation, the initialization helps ANSYS-Fluent to have a reference or an initial guess of the solution. In transient simulations, the initialization will indicate the initial values. So write 1.0 in temperature and then click on initialize. So now we are initializing our simulation. And now we will do the next step. We don't have any activities like autosave. We will review some of these later. And then we do run calculation. Okay. Our first simulation in ANSYS-Fluent for some of us, right? So we are almost there. Number of iterations. Select the number of iterations. That's the one that we are interested. So we will put, this is the maximum number of iterations. We will put 2000, right? And then we will do calculate. And now see what's going on in there. ANSYS-Fluent did something for us. If you do click in scale residuals, see, now ANSYS-Fluent run our simulation and it achieved the convergency value of 1 to the minus 12 at about 35 iterations. And these are the values of the residuals at every iteration. So we are done. We have seen this, right? So now what we will do is create a contour of the temperature. So go to results, then go to contours, then go to new, and then here, contours of what? Contours of temperature, static temperature. Then do click in display and see, wow, this is the temperature. See, if you do middle click and do rotation, rotating up and down, right? So you can do the zoom thing. Now this is your temperature, the temperature of the plate. ANSYS-Fluent has solved the energy equation for us. These are the results. We didn't have to use any advanced mathematical formulations. The software did it for us. Results shows that the temperature, a temperature of about 0 Kelvin at 0, right? And a temperature of about 0.91 at 1. Most of the plate has a temperature of what? Of 0.5 kelvins. So the results look kind of good, right? The thing is, and the one that makes me feel uncomfortable is I was expecting to see a temperature of 1 at y equals to 1, and that's not, ANSYS-Fluent is not showing that. So, but what we will do next is refine our mesh and see if the results improve. So now we will close this. First, save your project. And then click on OK. Okay. So now the project has been saved, then file, and the close Fluent. So now we are closing Fluent. Now go to your Workbench and see, we did the setup and we did the solution. So everything was updated for us, right? We don't have to deal with this anymore. We're almost there. The only thing missing is the results. So now click on results. Just want to make sure that this is being recorded. Yeah, okay. So now click on results. So double click. And now ANSYS-Fluent is opening the software called CFD Post. This software will allow you to create more, to create better figures and even to extract your data. So it will allow you to create more professional plots. So, and you will be able to export your results into an Excel sheet so you can plot them in MATLAB or other similar software. So we will create a contour of temperature. So first, click on the Z-axis. And this is your view now, 2D view. So we will create a temperature contour. So click here on contour. And name this as temperature contour. Then click on OK. And now this appear, right? So domains, all the domains, location, we want the temperature contour at the plate. So select symmetry. Then the variable, select temperature, range, put local, and then click in apply. So now see, this is now your contour. Now you can use these toolboxes, right? You have different tools or icons to visualize or to play with your geometry. So we can move the geometry by clicking on pan. You can move it around. You can make zoom. See, you do click and up and down. Click, hold the click and do that, go down, and it will do zoom out. But if you do click, hold it, and go up, it will do zoom in. And there are other tools, right? So what we will do is save this picture. So file, export, No, file, save picture. And just make sure that you know where your file is being saved. So it's being saved in my desktop. Then I created the folder to the SSHD. And then there is another folder called Project One Files. And then there is another folder called User Files. And it looks like ANSYS-Fluent will save my picture in there. So I will name this picture as temperature, no, solid plate temperature. I will call it mesh 1. And then do click in save. And now we will also export the data. So click in file, export, then export again, and see, it is going to extract your data into a file, into a CSV file. What is a CSV file? The name stands for comma separated value. It's basically an Excel file. So name this file as solid plate temperature. And then mesh 1. And then click. So type generic location, symmetry, internet, the units is fine. And then click in save. No, select variables. For select variables, select your temperature. I want the temperature and click on save. So now let's go to the folder where the data is being saved. So see, I am in my desktop, then to the SSHD, project one files, then user files, and see, the two files that are created are in there. So this is the contour of the temperature. And now this is the Excel file, right? And it gives you the X, Y location of your computational cells. It also is giving you the Z location of your computational cells, but see, the Z location is not changing. It's the same for everyone. So you can ignore that one. You can even delete that one because it's not changing. So it's X, Y, and the temperature, right? Now you know that at X equal to 5 and Y equals to 0.9, the temperature is 5. If you go down and at X equals to 0.9 and Y equals to 1, the temperature is 5.24, 0.524, right? Now you can open this file in MATLAB and create a better contour plot for you. You can do lots of things with this file. You can estimate the mean value, plot some results, plot you can plot what is the temperature along this y-axis at a certain x location, right? So you can do lots of things. Okay, so we are done with our results. Wow, this is great. We just finished our first simulation. So do file, save project, and then file, close. And guess what? Guess what? We have completed our first project in Ansys Workbench. Okay. So now the next thing that we will do is analyze the effect of our computational mesh. And I will show you some tricks to do that easily. First, save our project. Then right click on fluid flow. And then, so it's right click and then duplicate. So now ANSYS-Fluent is duplicating our project. Right, so now let's rename this project. So click on the name and just put in here mesh 2 and remove the name of copy. So now click on mesh because we want to refine the mesh and see if the results improve. Remember, we want to see a value of a temperature of 1 at y equals to 1 and x equals to 0. Right, so now go to your mesh and I will show you a trick in here. I don't like these deformations at all of the mesh. So right click on mesh, then insert, and then do face meshing. Then click on your geometry or on the heated plate, on the solid plate, click there, and then click in apply. Now go to your mesh, do right click and do update. And see, this is a beautiful mesh. So now what we will do is increase the number of elements in the y-axis. We will put 30. Let's put 20, right? Then right click on mesh and then update. And see, now we have more computational cells along the y-axis. So now do file, save project, and then go again file and close meshing. Now, we don't want to do the setup again, the solution again. ANSYS-Fluent will do that for us. So what we need to do is right click on setup and click on refresh. And now right click on setup and click on update. So now see here, ANSYS-Fluent is starting and is doing all the setup that we did in our previous project. So it's assigning copper to the material, is also defining our boundary conditions, is also doing all the things that we did, right? Defining the temperature at the heated plate and so on. So now it's done with that. Now do the solution for us to ANSYS, please. So right click on solution, then click on refresh. And then right click on solution and click on update. So now ANSYS-Fluent is now doing the simulation for us. So let's wait a little bit. It's loading the mesh and model information. It's initializing and now it is solving. And now it's updating the solution. See here. And now we have the solution. Okay, so now let's do our results. So right click and then refresh. Okay, so it didn't ask us to update our results. So, okay, so what we will do is double clicking results, and ANSYS-Fluent will start off our results, right? And now, see, now the temperature is getting closer to 1. The temperature at y equals to a or at y equals to 1, it should be 1. Remember in our previous plot, it was 9.9 what? Let me check that. So in our previous mesh, right, it was 9.0. Now it is 9.5. So it's getting there. It's getting there. So it means that the mesh is an important parameter. So what we will do is file, export, file, save picture, and solid plate temperature mesh level. We will name it mesh 2. And then do click in save. That's there. So now we will also export your data. Export, export, and then name it mesh 2. CSV, everything remains the same. Just click on save. Then file, close. So now we are done. We are done with our second mesh. Let's do one more level of refinement. See if we can get there and have a value that is very close to 1. So right click and then, so right click on fluid flow and then duplicate. And rename this. So remove the copy of and put it mesh 3. Oh, okay. So before we continue, remember, it's very important to save our progress. So now everything is safe. Now we need to do what? Update our mesh, right? We need to refine the mesh, make it more finer, and see if we can get better results. This time we will refine the mesh in the y-axis too, no, in the y-axis and in the x-axis, and we will kind of increase this number a lot. So let's put 150 for the, so I remember I did click in mesh, then edge sizing, and I put a number of 150. Then I do click in edge sizing too. So instead of having 20, I will put 55, right? Then right click on mesh and then update. So now it's a much finer, it's a finer mesh, right? So now file, save project, then file, close meshing. And now let's do the setup, the solution, and the results the same way we did it before. So right click on setup, then refresh, to right click again and click on update. So now see, starting Fluent, it says here. So Ansys Workbench is starting Fluent at this point, and now it's loading the mesh and it's also putting the model information that we defined. Then do the same for solution, right click, refresh, right click, update. So now it's updating the solution. Because it's a finer mesh, it may take a little bit longer to complete the simulation. Okay, so everything is done. So right click on results, then refresh. It didn't ask us to update anything. So what we will do is click on results, double click on results. So it will open CFD post. Oh, it's getting there, right? 9.81, 9.81, right? So not there, but almost there, right? See, the results are improving. So you can do, now what we will do is file, save picture, and then do mesh tree. And do save. File, export, export, and then mesh tree. So we change the name, everything remains the same, and then save. So this file, close CFD post. New file, save. So guess what? So now we have the 3 results for our mesh. So now you can see for mesh 3, the value is 0.98 at y equals to 1, which is kind of close to the expected value of 1. And remember, this is not the value at the edge, it's more like the value at the center of the computational cell. So there's still, it's still kind of good, but you can keep refining your mesh and get better results. And you can do lots of things like you can customize your mesh, make it more refined here than in here, because yeah, there are lots of things you can do to get the right result. So let's close this. So this concludes basically our exercise. For this simulation, hopefully you were able to follow each of the steps. Please let me know if you leave any comments with questions. And the next thing is file and exit, right? So thank you.